the curve r equal to a plus b cos theta, where a equal to b and a and b both are greater than or equal to 0. So r equal to a 1 plus cos theta. Since a equal to b, a plus a cos theta, so taking a common, we have r equal to a1 plus cos theta. This curve is known as cardioid. So we'll start with the first point, that is symmetry. So when we replace theta by minus theta, we have r equal to a1 plus cos of minus theta. Cos of minus theta is equal to cos theta only. So again we'll get the r only. So if we replace theta by minus theta, the equation of curve remains unchanged. Therefore curve is symmetric about the initial line. Second point is pole. So for r equal to 0, we have a 1 plus cos theta equal to 0, that is cos theta equal to minus 1, and therefore theta equal to pi. Therefore curve passes through the pole. Since curve passes through pole, we have to find tangent to the curve at pole. For that again we have to substitute r equal to 0 in the equation of curve. So r equal to a1 plus cos theta, substitute r equal to 0. So again we have a1 plus cos theta equal to 0, that is cos theta equal to minus 1. Here fortunately we have only one value of theta, and that is theta equal to pi, and this is the only tangent to the curve at pole. Now we want to check the existence of curve. So when theta equal to pi, r equal to 0, and this is minimum value of the theta. So while taking minimum and maximum value, remember that we have to take positive values only. So for theta equal to 0, r equal to 2a, and this is the maximum value of r. So since minimum value is 0 and maximum value is 2a, the whole cardioid lies inside the circle r equal to 2a. Next is table of values. Since curve is symmetric about initial line, considering values of theta from 0 to pi only. So since it is symmetric about initial line, we are taking values from 0 to pi only, and for the remaining part we'll consider symmetry to trace the curve. So now let me take different values of the theta. So theta equal to 0, pi by 4, pi by 2, 3 pi by 4, and pi. And corresponding value of r obtained from the equation of cardioid r, 2a, a 1 plus 1 upon root 2, then a 1 minus 1 upon root 2, and then for theta equal to pi, r equal to 0. So 2a as it is, 1 plus 1 upon root 2 is 1.7, then a as it is, 1 minus 1 upon root 2 is 0.3, and then 0. So now draw the initial line, that is OX. Then as we know that whole curve lies inside the circle r equal to a, the circle having center at pole and radius a is drawn. So this is the point a0, 0 degree in fact. This is the point a pi, this is the point a pi by 2, and this is the point a 3 pi by 2. Then considering the symmetry, it is sufficient to trace the curve above the initial line only, and by symmetry we can trace the curve below the initial line. So after symmetry we have seen the pole. As we know that curve passes through the pole, so one point on the curve is known, that is pole. Then after that we studied that theta equal to pi, this is the tangent to the curve. So theta equal to pi is tangent, this is tangent to the curve. Next we considered a table. There we consider that when theta equal to 0, r equal to a, so this is the point a0. When theta equal to pi by 4, r equal to 1.7, so this is 1.7a, and pi by 4, this is the point. Next is when theta equal to pi by 2, r equal to a, so this distance is a pi by 2. Then after that when theta equal to 3 pi by 4, r is equal to 0.3a, 3 pi by 4. And the last point is when theta equal to pi, r equal to 0. So join all these points, and by symmetry we can trace the remaining part of the curve. So in this way we get the cardioid which lies inside the circle r equal to a. This is one of the cardioid. In the same way, there are 4 different cardioids. We want to understand them and try to trace. We have traced the first cardioid. Now you try to trace the second, third, and fourth cardioid. For your information, I have given the how the cardioids looks like. So first is r equal to a1 plus cos theta. So how to remember this? When theta equal to 0, substitute theta equal to 0, cos of 0 is 1, so 1 plus 1 2, so r equal to 2a. So maximum value of r is 2a, and we get the maximum value whenever theta is equal to 0. So along theta equal to 0, the cardioid lies. So it is like this. Same concept I will use for the next cardioid also. So r equal to a1 minus cos theta. So in this case, when theta equal to pi, cos of pi equal to minus 1, minus of minus 1 is plus 1, so r equal to 2a. So maximum value of r is 2a, and we get the maximum value whenever theta equal to pi. So the cardioid lies along theta equal to pi, and the cardioid is like this. So size of cardioid is same, it lies along the different lines. Next is r equal to a 1 plus sine theta. So whenever theta is equal to pi by 2, r is equal to 2a, and therefore cardioid lies along the line theta equal to pi by 2, and the cardioid is like this. Last is r equal to a1 minus sine theta. In this case, when theta is equal to 3 pi by 2, so 1 minus sine of 3 pi by 2, sine of 3 pi by 2 is minus 1, minus of minus 1 is plus 1, so r equal to 2a. So maximum value of r is 2a, and when theta equal to 3 pi by 2. This is the line theta equal to 3 pi by 2. This is the initial line. So the cardioid lies along the line theta equal to 3 pi by 2. It is like this.